Hi, I hope you're doing well. In this lesson, we are going to look at stoichiometry of chemical reactions. Chemical reactions can be presented by a word equation or a chemical equation. When particles combine in chemical reaction, they do so in certain specific proportion referred as mole ratios. The concept can be used to write balanced chemical equations for the reaction. There are several steps to follow, and these steps are: 1. Reactant and the products must be known. Then step 2, write a word equation. Step 3, write in symbols the correct formulae of the reactants and the products. Step 4, balance the number of atoms of each kind on either sides of the equation. In case you have any challenge, you can refer from to topic 1, structure of the atom and the periodic table. A link will be provided below this video. Step 5, include the state symbols for the reactant and the product. Again, if you have a challenge, refer from to topic 4 on salts about solubility rules. A link also is provided under this video. In a balanced chemical equation, the quantities of reactant and product are whole numbers ratio. For example, if you are reacting magnesium and chlorine gas, you form magnesium chloride. So this one is balanced. We have 2 chloride ions and we have the molecule here with 2 atoms of chlorine. Magnesium 1, magnesium 1. So the ratios are 1:1:1. That is why it is 1:1:1. In the second part, magnesium is reacting with oxygen gas to form magnesium oxide. In this case, you need to balance the equation by putting a 2 here, because we have 2 atoms of oxygen in one molecule. So to make this one 2, you put a 2 here, meaning you change the number of magnesium atoms on this side, so they become to be 2. Therefore, you need to put a 2 here. So the whole number ratio or the mole ratio is 2 for magnesium, 1 for oxygen gas, and 2 for magnesium oxide. A chemical equation in which the reactants, these ones, reactants, and the products are in whole number ratio, they are called stoichiometry equations. Like this one is a stoichiometry equation and this one is a stoichiometry equation. Simple. When a chemical reaction takes place between aqueous ionic compounds, only certain ions combine to form either solid, liquid, or gas. Example: consider reaction between barium chloride and sodium carbonate to form or produce solid barium carbonate and aqueous sodium chloride. So in that type of reaction, if the stoichiometry chemical equation is given, or it's done this way: barium chloride, barium has a valency of 2, chlorine 1, so that's the formula of barium chloride. Sodium carbonate, valency of 1, carbonate radical has a valency of 2, so they interchange to form that. Then the product will be barium carbonate and sodium chloride. So in this equation, you now dissociate the aqueous into ionic. So barium will be having that way, and then after doing that, you'll find that there are some ions which are either side of this chemical equation. Those ions that do not change are referred as spectator ions, and they will be cancelled or omitted. Chloride appearing this side, and also this side, so we cancel. And it is good to note that the 2 stands for sodium and also for chloride ion. That is why we have the 2 here and 2 here. Then the other ions are sodium ions, you cancel with that. So your ionic equation will be barium ions aqueous plus carbonate ions aqueous to form solid barium carbonate, which forms a precipitate. Chloride ions and sodium ions, as higher I've stated, do not undergo change during the reactions, hence they are referred as spectator ions. They are omitted or cancelled out when writing ionic equation. Example 2. When magnesium sulfate and lead nitrate react, they produce magnesium nitrate and lead sulfate. This is the equation. Magnesium sulfate. Need to remember the valencies of magnesium, like this one is 2 and this one is 2. Lead is 2, nitrate is 1. So they form magnesium nitrate and lead sulfate. The stoichiometry chemical equation is that one. So those which are in aqueous form, they form the ions: magnesium ions, sulfate ions, lead ions, and nitrate ions. On the other side of the product, we have magnesium ion, we have nitrate ion, but lead sulfate, because the solid does not form the ions. Therefore, we look at the spectator ions. Magnesium is 1. Then we have sulfate, no. We have lead, no. But we have nitrate, which are spectator ions, so you cancel them out or you omit in the equation. So after doing that, you will find that sulfate ions combine with lead ions to form solid lead sulfate, form precipitate. Also, you can try reacting, or you try to come up with the ionic equation when you react lead nitrate plus potassium iodide. You'll find it will form solid lead iodide. Try this one. Displacement reaction, we have copper sulfate reacting with iron 2 solid. So when copper sulfate, which is aqueous, combined with iron is more reactive than copper, so it displaces copper from the sulfate to form copper metal and iron 2 sulfate. So the spectator ions, which are the ions appearing on both sides, we have copper no, sulfate and sulfate are appearing on either side, so they did not take part or they did not undergo change. So you cancel sulfates and also you cancel the sulfate. So the ionic equation will be copper ions aqueous plus iron from iron to form copper solid and iron ions. Remember, don't forget to put the state symbols, okay, and then don't put this one as an equals. It is always given like with an arrow, not equal sign. Here is a quiz for you to test your understanding of the concept of stoichiometry of chemical reactions and also writing the equations. Thank you, bye bye, and let's meet in the next lesson.